Hello, my name is Chuck Ridgway. I'm the Automation Technology Manager at Horner Automation. Now, for those of you who aren't familiar with us, we're a U.S. manufacturer of all-in-one controllers. What is an all-in-one controller? Well, it's a component that combines the functionality of a PLC with an operator interface, with built-in I/O and lots of networking capability, all programmed with a single software package that's free, by the way. So if you haven't checked out our products yet, I'd encourage you to do so. I know a lot of you are struggling to source your normal controllers and PLCs, etc. At Horner, we've been able to stay way ahead of the game in terms of maintaining close to normal lead times. Okay, now every Tuesday here at Horner, we host a live stream with another technical topic. Sometimes that technical topic is very specific to our products, and other times it's a little more general purpose by nature. This week is one of those general purpose topics. It is comparing Ethernet IP, Modbus TCP, and Ethernet global data. So Ethernet protocols are always a subject of subject that people want to learn about. And today we're going to get you this topic that hopefully you'll find very useful. Okay, so those of you who are watching live, the advantage of watching live is you can ask any questions you may have in the chat section, and our experts are standing by to answer those live. For those of you who are watching on replay, give us your questions in the comment section. We will just answer those in non-real time. Okay, let's go ahead and get started. Let's start out today by talking about why we are comparing these industrial Ethernet protocols. What's our motivation today? Well, as a 30-plus year automation engineer, one of the questions I get very frequently is, which protocol should I use in my application? I think there's just a lot of uncertainty or maybe a lack of clarity among automation users as to which protocol is best in which application. So that's certainly an area of motivation today. Also, Ethernet IP and Modbus TCP are two of the very most popular protocols out there. And one thing I noticed when I did some research is there's not a whole lot of content out there that's available that compares the two directly. So I thought we'd do that for you today. Also, the third protocol I'm going to talk about today isn't anywhere near the level of popularity as the other two. Ethernet Global Data is a protocol that is not widely promoted. It's not widely implemented. And I think it needs a little bit of love out there because it's really what I would consider an underrated protocol. And we're going to talk about that one as well. And then finally, these three protocols happen to be the three most popular protocols used on our OCS all-in-one controllers. So again, there's motivation for the topic today. Now let's talk about how we are comparing these protocols. We're going to start with their origins, where they came from, who is promoting them. What data model are they based on? What messaging types are used? UDP versus TCP, for instance. What are the strengths and the weaknesses of these protocols? There is no perfect protocol, and there are plenty of other great protocols as well that we're not going to talk about today. EtherCAT and Profinet to name two, and while those are terrific protocols, they're not perfect either. So we're going to talk about the strengths and weaknesses of these three protocols today. Of course, we're going to talk about when and when not to use these protocols. And then at the end, we're going to get to a little bit more specificity about the Horner products and talk about the best applications with these protocols with our Horner OCS all-in-one controllers. Let's talk about the origins of these protocols. In the industrial world of protocols and networking, generally, most protocols have been around much longer than you might think, with the majority of today's protocols being invented in the 90s or 2000s from an Ethernet standpoint, and their origins typically are even older than that. So let's start with Modbus TCP. It is thought of as Modbus over Ethernet. Modbus protocol was developed in the late 70s by Modicon as a serial protocol, typically used in RS-422 or RS-485 or sometimes RS-232 type media. And then as time went on and Ethernet became popular, basically Modbus was adapted to Ethernet as well. Now, even though Modicon, who is now, I guess, technically owned by Schneider, even though they were the inventors of the protocol, it's generally thought of as a very general purpose protocol. It's not really thought of as being, a Modicon or Modicon specific protocol, for instance. Next, what about Ethernet IP? Well, you could kind of think of Ethernet IP as DeviceNet over Ethernet, because Ethernet IP doesn't have its origins, at least the protocol behind Ethernet IP doesn't have its origins strictly in Ethernet. It started out as a protocol that was used over CAN, called DeviceNet. It's called Common Industrial Protocol these days, and it's been adopted to a variety of media. And Ethernet just happens to be the most popular one for sure. Now, even though this is a totally open protocol that is embraced by multiple manufacturers, I still think that a lot of folks think of it as being commonly associated with Rockwell. And that's because Rockwell has such a large market share and because that's the protocol that they use on their products. So I think generally people do think Rockwell when they think Ethernet IP, even though, again, many manufacturers have embraced it. Now, Ethernet Global Data, again, that's a much different animal than these first two. What is similar is that it's a protocol that was invented quite a while ago, and that is, it was invented as a joint effort between GE Automation and GE Drives, those two divisions of GE back in the 90s. And it was never widely proliferated. It was used pretty heavily on the GE products. And at Horner, back in the 90s especially, we had a strong affiliation with GE, so we applied it quite often as well. But again, it has not proliferated widely like the other protocols have. Let's next talk about the data model that these protocols use. And let's start with Modbus TCP. And Modbus TCP, as I just mentioned, was based on Modbus. And Modbus was invented in the late 70s. So in the late 70s, it made sense to model the protocol on a traditional PLC, which were register-based at the time strictly, which strictly consisted of data types of integer and Boolean. Now, over the years, as things evolved, other data types, of course, became popular, like floating point, double integer, etc. And basically, even though the protocol wasn't necessarily adapted directly, or at least officially, for those other data types, companies like Horner and many, many, many others did adapt Modbus to support additional data types by concatenating together integer type values, or at least word type registers, to create basically floating point, double integer, and other data types. Modbus also includes a address scheme or addressing scheme that traditionally is a 5-digit address that consists of 4 different types of data: coils, inputs, input registers, and holding registers. That's Modbus. That's the origins of the data model of Modbus. I'm going to mention Ethernet Global Data next because, like Modbus, Ethernet Global Data was created in the day where a register-based PLC was the norm. So Ethernet Global Data's origins very similar to Modbus. It's just that it doesn't have the specific predefined Modbus addresses, but it is also based upon an environment of Boolean and word type variables, but has been later adapted to include 32-bit type data types. And then let's talk about Ethernet IP. And even though that's no spring chicken, DeviceNet was invented in the 90s and Ethernet IP was adapted, I think, in the early 2000s. It is pretty much based, from a data model standpoint, it is based more on an object model as well as tag-based type variables as opposed to register-based type variables. So those are some differences in the data model between those protocols. The next thing we're going to talk about is the types of messaging used in these 3 protocols. But before we dive into the specifics of each protocol and its messaging, let's talk in general about TCP versus UDP messaging. Let's start with TCP. So TCP stands for Transmission Control Protocol. It's a connection-based protocol. What does that mean? Well, that means that effectively 2 devices have to establish a connection with each other before they can really start exchanging data. TCP has error recovery built in. So if you send a TCP message and there's a problem with that message getting through, there is an automatic retry mechanism that's right there built into the protocol. So that's an advantage, but it's also a little bit of a disadvantage because there's plenty of extra bytes that get sent along with the data when you send a TCP message. So that means that as a percentage of the number of bytes sent over the wire, the data is smaller, the data percentage is smaller than you might find in UDP that we're going to talk about in a minute. So technically it's a little bit slower because of that. And one other thing to mention about TCP, and that is it is a unicast style connection where it's one device talking to one other device, strictly unicast. Next, let's talk about UDP, or User Datagram Protocol. That's a connectionless protocol. So pretty much two devices can just start communicating right off the bat. Error recovery is not built in. It's the responsibility of the receiver. So if you're a device that's expecting to receive data over UDP, you better be configured or be ready to react appropriately if that data you're expecting just doesn't come in. So that's definitely something that you have to take care of outside of the protocol with UDP. Because of the fact that there isn't a bunch of extra bytes affiliated with retries and those sorts of things, it has lower bandwidth requirements. So there's some customers that like to use UDP protocols, for instance, over cellular, because they know there won't be any automatic retries going on, which means that they can have more certainty as to how many bytes get sent out over the wire, and there won't be a bunch of retries they don't know about driving up their data bill. Anyway, technically it has lower bandwidth requirements, at least in terms of the fact that there's no error checking built in, which technically makes it faster. Now let's take a look at what messaging is used by which of these three protocols we're looking at today. Okay, let's start with Modbus TCP. Yep, that one's pretty obvious. It's using TCP, and it's using it in a pull response type approach. So that is where you have a Modbus TCP client, which is sending out queries to a Modbus TCP server who is responding with a reply. And that's the pull response approach to Modbus TCP. Now, several of you may be thinking, now, wait a minute, I know I've heard of Modbus UDP. What about that? Well, it does exist. It's not as popular as Modbus TCP, and we're not really going to talk about it today. What we're primarily going to talk about is the TCP version of Modbus, which is by far the most popular over Ethernet. Next, let's talk about Ethernet IP and its messaging. Now, Ethernet IP is a little bit unique in that it's kind of two protocols in one from a messaging standpoint. So it does use TCP for a portion of its messaging. It does have a pull response type set of messages called explicit messages, and TCP is used with Ethernet IP for those types of messages. Those are things like maybe setup data or configuration data, that sort of thing. And then it uses UDP, which is a producer-consumer model, for its IO type messaging, which is called implicit messaging. So it uses both TCP and UDP. That makes it a little bit unique. Now, Ethernet Global Data, which is my third protocol that I'm telling you all about today, it's strictly a UDP protocol following that consumer producer model. So in the case of the implicit IO messaging as well as the regular messaging for Ethernet Global Data, you don't have any retries built in to the protocols. But both of those parts of the protocol, both those UDP protocols, they support, in addition to unicast, they also support multicast, which allows not just one-to-one communications, but multicast allows a single device to send data that's received by multiple other devices from that same message. So you don't have to take the same message and repeat it over and over again. You can send that one message in a multicast scheme, and multiple devices will receive that one message. So it helps conserve bandwidth in that way also. Now, as I mentioned in my opening, there is no perfect protocol, right? Even though there's 6 to 10 choices these days in the marketplace, there is no perfect protocol. So we're going to talk about strengths and weaknesses of each of these three protocols. Let's start with Modbus TCP. Modbus TCP is a simple protocol with wide support. That's its biggest strength. There are a lot of automation companies out there that might manufacture simple devices, and those automation companies are experts at that simple device, that sensor or that actuator, whatever the case may be, but they're not necessarily experts at communication. So Modbus is a simple protocol that's straightforward to implement, and that's why it has been implemented over the years on so many different devices, and that's carried through with Modbus TCP over Ethernet. It's a simple protocol with wide support. Another thing I'll mention, and that is Modbus data is a register-based type data. It's a two-way type data. What does that mean? Well, with For instance, with Ethernet global data and with the implicit or I/O messaging that's built into Ethernet IP, there's data that goes out to the network and there's data that comes from the network. So it's really separate variables are produced and separate variables are consumed. With Modbus TCP, the register data is basically two-way, so it can be read or written by multiple devices on the network talking to each other, which can be a real advantage. An example would be maybe a host software package like a SCADA system. It might be polling a PLC in the field, and there might be a set point for a PID loop or something like that. And that set point can be modified locally in the PLC, or it can be modified remotely in the SCADA package, and that same variable can be modified by either of those parties in the communication. So that's a real advantage to Modbus TCP. Now, disadvantage. Because Modbus was created in the days really before 32-bit data types were prevalent, like floating point, etc., you can have word order or byte order compatibility issues. In other words, some manufacturers may not really follow the best practices in terms of the order in which data gets sent out over the wire, and it's possible for words or bytes to become switched. Now, it's not super normal, but it does happen way more than other protocols. So that's something to be aware of. And because it is a relatively simple protocol, it can have compatibility issues because they didn't think it was complex enough to have a body that does any kind of significant certification. So compatibility issues can happen with Modbus. And because it is a pull response type protocol, when you get a bunch of units talking to each other using that protocol, performance is limited. The type of response times that you can achieve are limited. Let's move on to Ethernet IP. Its compatibility is good because it's a well-defined protocol, and there are well-defined compatibility tests that are typically run on devices that talk on the network. So whereas Modbus TCP, that's a weakness, for Ethernet IP, that's a strength. Now, another strength of Ethernet IP is the fact that if you're using Rockwell, it's a pretty easy protocol to use. And that's because some of the things that can be complicated about Ethernet IP are kind of handled in some of the Rockwell software that you all are paying for when you are using those products. So some of the complexity is taken out with that software that you're paying for to solve your applications. That's a strength. Now, on the flip side, if you're not typically using Rockwell software, you're not typically using Rockwell products, it's not nearly as easy to use as otherwise. So that's something to keep in mind. So it's both an advantage and a disadvantage depending on whether you're kind of inside or outside the Rockwell walled garden of products and protocols. And the performance is just okay. There's nothing wrong with the performance, but it's certainly not industry leading by any stretch of the imagination. Next, let's talk about Ethernet global data, that third protocol that I'm talking about today. The Ethernet global data is really good at one thing, and that is it's very efficient at moving big chunks of PLC variable data. So if you have a few hundred words of variables that you want to move from controller to controller, Ethernet global data does that extremely well. Now, the negative, the big weakness to Ethernet global data is it's not supported by many manufacturers. If you're using the Horner products, we do support it, so it could be a real advantage to you. But if you're not using Horner products or maybe old GE products or something like that, or even some newer products from other manufacturers, then it's not available to you in those products. All right, now we're going to talk about when to use and when not to use these different protocols. Just give you some hints. So first of all, when should you use Modbus TCP? If you're looking to have devices from multiple manufacturers communicate with each other, Modbus is a great protocol. It's probably the best one out there. It's not perfect, but when it comes to wide adoption, I should say, and wide compatibility, it's the de facto standard. It's also a good solution when you need a host software package, maybe a SCADA package or something, to be able to exchange data with plant devices like PLCs, for instance. It's a protocol you'll find that's very prolific in both PLCs as well as in host software packages, and is often included for free with those host software packages. So that's another big advantage. If the device you're talking to is very simple, that's another time to use Modbus TCP, because there's pretty good chance that that simple device has at least implemented Modbus or Modbus TCP as its protocol. When shouldn't I use Modbus TCP protocol? Well, if a pull response type protocol is just too slow. Let me give you an example. Let's say you have 7 or 8 devices and you've got one client that's polling 7 servers. So there's 8 devices kind of communicating with each other in a round robin fashion. In that scenario, in that pull response fashion, your communication times are not going to be 10 milliseconds or 20 milliseconds or 50 milliseconds. You might be at half a second or a second or somewhere in that range. So if those type of response times are just too slow, then Modbus TCP may not be the protocol for you. And if you're primarily using Rockwell products almost all the time, then you may not want to use Modbus either. Well, what happens if you're using Rockwell and there's a device out there that you need to talk to that only talks Modbus? You can still do that. Rockwell does support an add-on instruction to do Modbus, but it's not ideal in the Rockwell world for sure. Now let's talk about when to use and when not to use Ethernet IP. If you're a Rockwell user and that's your primary PLC and automation product, you're going to be using Ethernet IP because Rockwell's going to mandate it, really. If you're using Ethernet, it's going to be Ethernet IP. And it's a good protocol, so there's no reason you shouldn't be using it. Or maybe Rockwell isn't your primary controller. Maybe your primary controller is somebody else's controller, but the machine you're building or the system that you're building, you want that to be compatible with Rockwell because it might be installed in a Rockwell environment, even though it's based on a different PLC or maybe even on a Horner OCS all-in-one controller. Well, if you still want that equipment to have compatibility with Rockwell PLCs, then adding Ethernet IP to your machine or to your system could be a really wise choice. Now, when not to use Ethernet IP, if you're not primarily using Rockwell and if Rockwell compatibility really offers nothing to you, then there's no real reason to use it. Finally, let's talk about Ethernet Global Data. When should I use Ethernet Global Data? So really, if you're a Horner user, then Ethernet Global Data could have some real advantages to you. So if Horner is your primary controller and you need to move chunks of variable data between controllers because you've got multiple controllers in the same system, Ethernet Global Data is almost always the best choice. You can get response time, 10, 20 millisecond type response time, and be moving literally dozens and dozens of variables and still keep that really good response time. That's definitely a case to use Ethernet Global Data. If you're not a Horner user, if you're not breaking up your control task into multiple controllers, or if a pull response protocol like Modbus TCP fits all your needs, then you wouldn't really need to use Ethernet Global Data. Last part of our talk today, let's talk about the specific applications for my product, the Horner OCS all-in-one controllers. What's some of the best applications for these different protocols with our products? Let's start with Modbus TCP. So the Horner OCS can be used either as a Modbus TCP server, where it's responding to queries from a client, or it can be the client itself, where it's polling multiple server devices, or it can be both at the same time. And there's some good applications for all three of these scenarios. In the scenario where the OCS is the server, it's a great way to provide access to all the OCS variables, or at least as many as you want to share, with a SCADA package or some other host software package, because it's probably not going to cost you anything extra on the host software side because it probably has a Modbus driver built in, and all the OCS memory types are all directly mapped over to Modbus data types as well. All right, now let's talk about a great scenario for Modbus TCP as a client with our products. So again, in that scenario, the OCS is polling other devices that are servers. Here's an example. You've got a variety of third-party devices, maybe variable frequency drives, etc., and you want to be able to control those drives and get diagnostic information and do fault resetting and all those sorts of things over a network. Well, Modbus TCP client executed in the OCS is a great way of doing that. And then here's another application that we talked about actually last week in our technical session last week, and that is you can use Modbus TCP, both client and server protocols together, in an application where maybe you have 2 or 3 OCS products on a machine or in an application, and you want your operator to be able to operate the system from any one of those screens. Even if only one of them is actually doing the control, You want to be able to have the ability or the flexibility for the operator to be standing, let's say, in 2 or 3 possible locations and operating the equipment. So that's another great application for Modbus TCP as a client or server. If you have more than 2 or 3 different OCSs involved with this specific application, you're going to probably be better off with Ethernet Global Data. But if you're just talking 2 or 3, you can get some excellent response times with Modbus TCP. Now let's talk about Ethernet IP. What are some of the best applications for that? Well, if the OCS is your primary controller for your piece of equipment, you're an OEM and you make a piece of equipment, and you want your product to have Rockwell compatibility, your machine to have Rockwell compatibility, even though it's not based on a Rockwell PLC, then you can simply add Ethernet IP I/O messaging to the OCS pretty much by just checking a checkbox and configuring just a very little bit of additional information. That's a big advantage. So now your equipment, even though it's not based on Rockwell controls, it can sit in a Rockwell environment and communicate back and forth with Rockwell products very easily. That's a great application. And in these days of struggling shipping by big companies such as Rockwell, you could even use one of our OCS products that all feature built-in I/O. Really, you can think of them as a nice remote rack of I/O. You can use one of our OCS products as a remote I/O drop on Ethernet IP. So if you just can't get Ethernet IP I/O, you can use one of our OCS I/O products for that very purpose. And we've got plenty of videos showing you step by step how to do that. And then in the scenario where you might want one of our OCS all-in-one controllers to act like an intelligent operator interface, communicating with say a compact Logix or Control Logix CPU, you can do that using something called Logix Tag Exchange. That allows an OCS to, again, act as an intelligent user interface because it's not just displaying data on the screen. It also has logic capability and built-in I/O capability and some additional functionality as well. Now with Ethernet Global Data, what are some of the best cases there? Well, if you are using OCS in your application and you are distributing the control task, in other words, you're breaking the control task down into pieces and having different pieces of the task being executed by different controllers, Ethernet Global Data is the protocol to use because you can literally move hundreds of these variables that are shared from system to system very quickly, very efficiently, and maintain outstanding response times with the data updates on the network. And as I mentioned, as one of the possibilities for Modbus TCP, if you have those applications where you want to use multiple OCS screens in an application just for user convenience, and you have more than 2 or 3 of those screens, Ethernet Global Data is going to be the best solution for that as well. I hope you found this topic useful. Most weeks we have hands-on, both in terms of our configuration software and in terms of our products, but this week was a little bit different. This week was really a more general market type discussion. And really what we talked about was the fact that all these 3 protocols that we're comparing, and even the ones that we didn't compare today, they all have their strengths and weaknesses. No one industrial protocol is best. And I will say one more thing. Don't be afraid to use multiple protocols simultaneously. If you have a host software program like a SCADA package, and it needs to be able to have access to your product or your machine, and Modbus TCP server is the best way to do that, use that protocol. But if you also want to provide access to or compatibility with Rockwell systems that are outside of your system, then also enable Ethernet IP as well. There's no reason why you have to stick to one particular protocol. That's one of the benefits of Ethernet, is the fact that you can have multiple simultaneous protocols working together generally in most products. And with the Horner products, we support a minimum of 16 simultaneous Ethernet connections, and it's usually more than that. Now, what some of you may not be aware of is that every Tuesday at 2 o'clock we have a different live topic that we cover. And this week, of course, it was comparing these 3 industrial Ethernet protocols. We always have someone standing by to answer your questions live, even if we had to pre-record the video. And if you're watching on replay, you always have the ability to get your questions answered by typing them into the comment section. Now, next week, we'll be back again with a more hands-on topic. So we're not just going to talk about it, we're going to demonstrate it, both from a software and from a product hardware setup standpoint. And that is, we're going to do PID tuning on the Horner OCS all-in-one controllers, and specifically we're going to do PID tuning on PID loops that have a digital control variable. So the output of the control variable isn't going to be an analog value, maybe going to a proportional valve or something. It's going to be a on-off bit that is going to turn on and off, let's say, a heater contact. That's specifically what we're going to cover next week in our hands-on session on PID tuning. Now, if you haven't done so already, I would encourage you to subscribe to our channel. Of course, it doesn't cost anything. If you choose notifications, you'll be notified every time that we go live or every time that we post a new video. Now, over the past couple of weeks, in addition to our live sessions, we've also posted a series of short videos that are also on the product pages on our website that give you a quick introduction to some of our key products, some of our key models of our OCS all-in-one controller. The Micro OCS X7, for instance, or the XL Series XL4, or the Prime Series Prime XL7. Those models all now have introductory videos that you can quickly watch to get a quick introduction to those products as you peruse our website. Of course, they're also available on our YouTube channel. Okay, so once again, thank you for joining me this week. I look forward to seeing you again in a future video, and let's all get out there and do some good this week.